picking up from where we left off in part 1. So we stopped once we got this graph in blue in part 1, which is actually the graph, and I think I said this, but just to reiterate, it's the graph of sine of 1/3 x minus pi over 3. We took only what's inside of that sine function into account, which accounts for the horizontal transformations in the graph. Now we want to look at what's going on outside of the sine function in this problem. And I actually, no, good thing I caught this, left off the +1 and the original function. Okay, so now we look at what's going on outside of the sine function. So we've got this multiple of -2 right here, and we've got this +1 out here. So the +1, that's the simpler transformation, so I'll go up to that first. That's just going to shift all the points on our initial graph up 1 unit. The -2, there's actually two things going on there. So the fact that it's negative, it's going to reflect the graph over the x-axis. It's going to flip it upside down. And the multiplying by 2 is going to change the amplitude from 1, as it is in that blue graph, to 2. You can actually accomplish both of these transformations in one step if you multiply the y-coordinates in that initial graph by -2. When you multiply by a negative, that'll change the sign on your y value, which will reflect the point over the x-axis. Take, for example, this point at 1. If we multiply by -1, it flips it down here to where y is -1. And the multiplying by 2 will stretch the amplitude. If the y value here is 1, multiply it by 2, that'll stretch it. So if you multiply by -2, that's going to flip it and stretch it. So you'll get both transformations happening at once. One last thing before I start moving some points here. Always do the vertical shifts, so up so many units or down so many units, do that last. So as far as the order here, we should multiply the y-coordinates by -2 first, and then shift them all up 1 unit. One last thing. Okay, so in part 1, and I'm sticking to this, you don't have to label every single x value on your graph. So if you've just labeled get my pointer, the initial x value and then the final x value for the complete cycle, and then you've clearly labeled your increments in between, then I can infer, okay, this is 2 pi, 3, 4, 5, 6, 7 pi. So I know what all these little dashes represent. And it's also fine if, like, when we were plotting points in part 1, we had 3 spaces here between those first 2 intercepts. So I went 1.5 spaces to plot this point. You don't necessarily have to label this x value, even if it occurs at like a halfway point. But if you wanted to, the way you would do that, you want to take an average of the 2 x values where you're trying to find the midpoint. So we have pi here, and if I just count 2, 3, 4 pi here. So if I'm wondering, okay, well, what's the x value here then? It's going to be the average of those 2. So let me do some scratch work off to the side. You have 4 pi plus the 1 pi over here, divided by 2. Again, we're just taking an average. So that's 5 pi over 2, which is, 2.5 pi, which is what we've plotted there. Now again, you don't have to label this x value, but if you wanted to, that's how you would do it. Okay, so now for those vertical transformations. Let me go point by point. So first this point. The y value right here is 0. So times -2, it's still 0. And then shift it up 1 unit. So that point is going to land right here. Okay. Here. The y value is 1. So multiply by -2. Now it's -2, which both reflected it and stretched it out. And then from there, shift it up 1, so you land right here. Okay, taking this point, the y value is 0, so times -2, still 0, and then shift up 1, so I get this point right here. And the same thing's going to happen with this point right here at 7 pi 0 times The y-coordinate times -2 is still 0, shift up 1. So I'm going to go ahead and plot both of those points right now. Where the y-coordinate was 0, it's going to change to 1. And so just one last point to plot. This point right here, if the y value right here is -1, so if I multiply that by -2, then that's +2 up here, and then shift up 1. So I get, oops, well, this point right here. And then here, if I just connect the dots now, and actually let me draw this a little thicker just so it stands out. Here is the final graph for y equals -2 sine of 1/3 x minus pi over 3 plus 1. Now we've taken everything into account, and that graph in red is your final answer.